Okay, so first of all, we're going to need a suitable replacement for cosine 2x. Because this is sine, I'm going to pick the one that has the relationship with sine. So 1 minus 2 sine squared x minus 3 sine x plus 1 equals 0. So I get minus 2 sine squared x minus 3 sine x plus 2 equals 0. Now, temporarily for a moment, I'm going to let y equal sine x. So then I could say this is minus 2y squared minus 3y plus 2 equals 0. And we notice this is a quadratic.
Mm-hmm.
So first of all, just going to divide it all by -1. Wait, 2 and 1, that would be 2, 4. Does that factor evenly? 1, 2. No. Doesn't factor evenly, so I might need to use a quadratic equation. Yeah. So I will have here x equals -3 plus or minus this should be a minus.
Wait, for this first part, cosine 2x, why would you use that formula when it's not squared?
Because cosine 2x is equivalent to that one. Yes, exactly. Oh, so wait, actually, hold on a second. Now I think it does work. -2. Yep. Because of this subtraction mistake, now it factors to 2y, y, and then I'm going to put my 1 here plus 2. Because that gives me 2y squared minus y plus 4y minus 2.
Right.
So now that means 2y minus 1 equals 0 or y plus 2 equals 0. Now I'm going to substitute the sine x back into y. It just makes it a little easier for me with the algebra part, and I see you kind of had done that a bit there too, so that's good. So now we know then that 2 sine x equals 1, sine x equals 1/2, sine x equals -2. And so this one we reject, because our sine values are always going to alternate between 0 and between -1 and +1. So this is the actual one that's the only possible solution. And we know sine of x is 1/2, or sine of 30 is 1/2. And the only places would be here for 30. And then also over here, which gives us a grand total of 150. So the two solutions we get are 30 degrees and 150 degrees. Those are the angles where sine of 30 equals a +1/2.